assignment will be doing this. What I've got here is a gray box. I'm going to cover up the graph. Now on your notes, what you can do is just you can use another piece of paper or your hand. Basically the way this works is you cover up the whole thing. This will help us, trust me, this will really help you identify the domain and the range much easier. So what we're going to do is list the smallest domain value. Well, domain values are all of the x's. So you'll look at the very smallest x value by moving over and trying to figure out where is this left side of the graph, the furthest thing to the left. Ah, there it is. Okay, so it starts at -2. So you come over to your graph and we're going to do a bracket -2. Now, why did I do a bracket? Because it is including the -2. If this had been an open circle, I would do parentheses -2 instead because it would not include that point. A bracket includes the -2. Then I'm going to say comma, and then it continues until you get to, now I'm going to keep dragging this thing over and revealing the graph. How far over does it go? It keeps going and going and going and going, and then finally it does not stop. It just keeps going forever, and so it goes off to infinity. So then I come right over here and say infinity. Okay, that was pretty bad. Now, infinity is always with a parenthesis. It does not ever have a bracket because we can never actually get to infinity. It's a number that just keeps going forever and ever. So we don't include infinity. We just say parentheses infinity. That is the domain using what's called interval notation. Now here's an inequality notation, and that's where we are just going to say, let me write it out here and I'll explain it. X is greater than or equal to -2. This is inequality notation where we use a less than symbol or a greater than symbol, and we say all of the x values that are from -2 on up. That's what this statement means. Okay, so these two things are exactly equivalent. It just depends on the directions of the problem, if it wants interval, if it wants inequality, or if it wants both. Now, all that work was just for identifying the domain. So now let's go back and identify what the range is. So we're going to go down here, cover this whole thing up again, and then we think, all right, range. Range are y values from the top and the bottom. So let's start with the smallest range. The smallest is going to be on the bottom. So we start moving this thing up, and there it is. So what's the smallest y value? It is a 3. So we're starting, let's go back to we're starting with interval notation. We go bracket 3, comma, and then you keep moving it up and up. And how far up does it go? Well, this is an arrow that really goes up forever and ever and ever. And so this one also goes on for infinity. And we do a parenthesis. Now the trick with the inequality is because we're doing range, we have to use a y value. So it's all the y values that are greater than or equal to, that are bigger than this y value. So it's greater than or equal to 3. All right, there's our first problem on those. Let's try another one. We're going to do the exact same thing with number 4. So either use another piece of paper or use your hand, and we will cover up that graph. Now to identify the domain, the smallest domain value, we will move this thing. Let's start dragging it, and we look for the farthest thing on the left, which in this case right there, it is a -2. Now it doesn't have a filled in circle, but on all of our graphs, we can assume that it is filled in right there, that it's actually touching -2. So we're going to say bracket -2, comma, and how far does it go? It keeps going to the right, it keeps going. So we're only looking at x values, and the x values keep going forever and ever and ever and ever off to the right. So it's just like example number 3, and this one goes to infinity. There we go. All right, how about the inequality? This one again is all of the x values that are greater than or equal to -2, just like the first problem that we did, or excuse me, the last problem we did. All right, range. Now we cover it up again, so cover it up with your hand or another piece of paper, and we're going to slowly reveal from the smallest range value, which would be on the bottom. So we start revealing, and then look here. What is the smallest range? There's an arrow here that it keeps going forever and ever. Therefore, the smallest range is -infinity, comma. Now how far up does it go? It keeps going and going and going and going, and it never stops. See, so the y values, if you notice, there's never a break in any y values. It keeps going forever. Therefore, we say it goes to positive infinity, close parenthesis. Okay, well, now how do you say this with inequality notation? You don't really do it like this. What you say is all real numbers. Now, all real numbers just means everything, but there's a shortcut to writing all real numbers, which is nice. It's this symbol right here. It looks like an R with two little lines on it. So it's an R with two lines. This stands for all real numbers. That can be placed right here as well if you want to just write it like that, all real numbers, instead of having to hand write it all out. It means the same thing. So these two things are equivalent. Okay, number 5. So let's try number 5 on your own. You're going to pause this video, try this one, see if you can get the same answers as I do. And just so you know, this red dashed line, that is just a little an asymptote to help you understand that the line is just going to gradually get closer and closer to that line. Never actually is going to touch it, though, on this example. And there's your answer to number 5. Let me show you how we do this one. It's a little bit more complicated than the ones we had before. So let's start off with domain by covering this up. Again, if you already have these answers and you know it's correct, if you want to skip ahead to the last problem, number 6, then you can do so. If you need some help doing this one, let me show you how it works. So as we start revealing the left side of the graph, the domain, the farthest one on the left, is actually negative infinity because it keeps going forever and ever. That's why I put a negative infinity right here. Then as we keep scrolling along, and we reveal, it stops once we get to the number 4. So the x values, we go off to negative infinity and come up here to the number 4, and it stops. But because it's an open circle, I put a parenthesis at the end. So negative infinity to 4. And that's the same thing as all of the x values that are less than 4. Not less than or equal to, just less than 4 in this case, because it's open. All right, now let's do the range. So the range, you start revealing the smallest range value. The ranges are the y, so you start on the bottom. And then you can see here it starts at negative 2. We assume with graphs that it actually touches that point, so we're going to say it's at negative 2 with a bracket. And then it keeps going. Now this is where it gets confusing for kids. They want to say it stops here at this value of negative 1, but it does not stop here because it's included there. So if you see, it's continuous this whole time. It never breaks of y values. Think of it like this. If I, as you're coming up here, right there at that point, it may not exist there, but it does on the left side, so you have to include it until you get to a y value of 3, which is the asymptote. So negative 2 to 3. And then the way you write the inequality is that it's the y values that are in between negative 2 and 3. All right, that was a lot. That was pretty quick. You might have to rewatch that part and rewind if you didn't understand this number 5. We're going to go on and do the last problem, number 6. Okay. This one's pretty tough. Let's get my box here to cover it up. So take your hand or another piece of paper, cover the graph up, and let's start with domain. Begin slowly revealing the left side to figure out the smallest domain value. And where is it? There it is right there. So we're going to start at negative 3, but recognize that it is an open circle, so we will do parenthesis. I probably should have written smaller. In fact, let's do that again. Write fairly small because I think there's a little bit more we're going to write on this one. So we start at negative 3, comma, and then let's continue until we get to where it stops. So here we have a vertical asymptote, and so it gets to negative 2 but never actually touches it. It's just going to approach negative 2. So we will say it gets to negative 2, close parenthesis. Now we do a union symbol, and we go back and start revealing. Okay, so there's a break here. When does it pick up again? It picks up right there at an x value of 1. So we're going to say it restarts at 1. It's an open circle. And then it continues until we get to what value? A value of 4. This is where kids will make a mistake by saying it ends at the value of 4. But if we do that, okay, don't write this part down. If we say 4 here with a bracket, then we'd say we're going to do a union of, and then we would continue on from 4. Well, that would make no sense because what we'd be doing is saying, hey, we're going to, let's get that out of the way. We're going to end at 4, include 4, start at 4 again. Well, really, we don't need any of this then. We don't need to say we're going to end at 4 and then continue on at 4. There was never a break here. So we just keep going until it finally stops, which in this case is at the value of 6. So we're going to say 6 with a bracket. So we go from negative 3 to negative 2 for the x values, and then we start here at 1, and we continue on. There's never a break. See, because at 4 here, it's still included. It never stops until you get to 6. There's interval notation. All right, now how do we do inequality? We're going to say, let's see here, we're going to have two statements. We'll say negative 3 is less than x, which is less than or, nope, just less than negative 2. And we also have, whoops, that's and we have 1 less than x, which is less than or equal to 6. So once you have the interval notation, you just kind of step by step write out the inequality notation. All right, let's see if you can do the range on your own. If you want to pause it right here, just finish this off, and that'll be the end of our lesson. I'll have the answers appear here, see if you can do that part right. So remember, the range, you're focused on the y values. And there's your answer to number 6. We have negative infinity to negative 2. As you reveal here, you can see why that is. Negative infinity because the arrow goes down, and then as you come up here, see there might be 2 pieces, but if you look at only the y values, these are the same y values. So it goes negative infinity up to negative 2. As you scroll up here, and then if you keep going, where does it start again? When you get up here to 3, and then it continues up until the y value of 6, and it stops. So you're looking at the y values again. Okay? You did it! This is Mr. Bean signing off. Rock that mastery check, and I'll see you back in the next lesson.